Talk a little bit about bond pricing. Now, you've been through this in corporate finance, so we will just go through this briefly. We know that the price of a bond is the PB, and that is the sum of the interest or coupon payments, that's C, discounted back, and number of periods, which is T, and the semi-annual discount rate or the semi-annual yield to maturity, which is R. So we discount that back, and of course we pay the par value at the end. So it's a series of payments, then the par value at the end. An example of that is the price of a 30-year 8% coupon bond, and the market rate is 10%. We would have 60 payments, which is 1 to 60. That would be the $40 payment. How did we come up with $40? It's an 8% coupon on a $1,000 bond. 8% of $1,000 is $80, and it's paid semi-annually, so you cut it in half. That gives you $40 here. The interest rate is 5% or 1.05. Where did we get that? Well, we have an interest rate of 10% in the market, and of course that's semi-annual, so we cut it in half, and we discount the $1,000 back 60 payments to get the principal to the future value as well as the coupon payments, and we end up with a price of $810. Now we know that the original coupon was 8%, and we know that the current interest rate is 10%. So the interest rate from the coupon to the market rate, the interest rate went up. So what happened to the bond price? The bond price went down. You remember all bond prices move inversely to each other, bond prices and the interest rates. So when interest rates go up, bond prices go down, and that's in this case. And if it was the opposite, if the interest rates have gone from 10% to 8%, this would be more than $1,000. So those are the bond pricing from corporate finance that you'll remember. Pretty easy to do. Of course, you can do that on a financial calculator as well. Prices and yields, required rates of return, have an inverse relationship. The curve 1413, which we will talk about as convex. The longer the maturity, the more sensitive the bond's price to changes in market interest rates. So here's figure 14.3, the inverse relationship. As you can see here, $1,000 gets us the 8% relationship between our original par bond of $1,000 at 8%. Interest rates have moved up. As interest rates move up, we go down the curve, and we find that $810.71 is the now interest price of bond prices and yields. You can see this curve gets steeper as it moves up, and the longer the duration, the more change there actually is. So as you go further out the curve, the more change there will be. So that's pretty easy to see in these curves. If we go to the chart, we can see the difference in the numbers. The years to maturity along the first column here, we've got 1, 10, 20, 30 years in this chart. And of course, the maturities across the top, 2, 4, 6, 8, 10. As you can see, a 1-year bond with 2%. This is the bond price given a market interest rate is 2%. This is the 8% bond as the benchmark. 2%, the interest rates have gone from 8% down to 2%. The bond price has gone up to $59 for 1 year. 4%, it's $38. 6%, it's $19. So you can see the further you move away from the par, the bigger the change in the bond price. Obviously, everything over 8% will be lower than $1,000. And also the duration, or the time to maturity, I shouldn't say duration, I should say time to maturity. The longer it is, the bigger the price change, of course. So if an 8% 30-year bond starts out at $1,000 and interest rates drop to 2%, you've more than doubled your money simply because interest rates have gone down. And so that's a fantastic return on your money. But you would have to predict that interest rates were dropping from 8% to 2%. So the difference in interest rate changes the bond price. They move inversely, as you know from corporate finance. And these are just a chart to remind you of that difference. Let's move on.